Hello, hello. So this will be the video to help you work through exercise 4. In exercise 4, we will start the first of the 4 main statistical tests that you learn in this course. So this very first one is called a t-test. Very, very briefly, you can obviously read the whole thing in your textbook, but very briefly, a t-test is a test where you are looking at the difference in means between two groups. T-test looks specifically at two groups. Next week, we'll start with ANOVA, and that looks at more than two groups. But this will specifically look at the average, the difference in the average between two groups, and you're trying to examine if there is a statistically significant difference between that average, basically, in those two groups. So, for example, you could look at the average income between men and women, right? That would be, you have your two groups, and then you would have a continuous variable where you're able to calculate the average. So, just as a general example, right? So, again, as with the others, you will need to download the file for exercise 4. There's obviously a page here that will, you'll do some regular schmegular stuff. I will also upload, again, an older PowerPoint from an older version of this course that I taught that will have all the formulas. It'll just be in there, so you don't have to go hunt for them in your book, but it'll be in the PowerPoint. And I will make a note of that in the module as well. But anyway, it'll be in the PowerPoint. If you're watching this first, it's in the PowerPoint. Okay, so we are still using the 2021 GSS. What I've done here, you have two different kind of research scenarios that are typed up here. So I'll go through the first one with you. The second one you will do on your own, just like all the other ones, and I'll kind of describe each of the pieces as we go through it. So, you have kind of like a little bogus scenario that I've given you, right? So you're looking at if there's a difference in the average age of people who voted for Hillary Clinton in the 2016 election and the average age of people who voted for Donald Trump in the 2016 election. I've told you to assume an alpha, that's what this little squiggly A is, of 0.05. This matters for when we're determining the significance. Basically, the very basic way to think of an alpha is we're pretty sure, we're 95% sure, that's what the 5 is. It's like 5% is, it could still be. We're 95% sure that the difference that we have between these two groups, that any difference that we're observing between these two groups isn't a fluke. That there's something statistically different between these two groups. In this case, since we're looking at mean difference, right? So that 5% is that's a threshold that we want to meet. This can be changed. This could be 0.01, which would be you're 99% sure that, there's an actual difference going on here. And so on and so forth. There's also 0.001 is another alpha that gets used a lot in at least sociology research. You'll see people denote that sometimes. So you're using age, because you're looking at the difference in the average age, right? And then the other variable is called Pres16, where 1 is coded as those are the folks that voted for Clinton, 2 is people that voted for Trump. So I've given you both variables in your scenario as well as your alpha. I will pretty much never ask for a different alpha. I just want you to be aware that it exists, conceptually. So the very first thing that you'll do on any of these, and this goes for not just the t-test, it goes for the rest of your exercises as well, is you'll write your null hypothesis. So a null hypothesis is basically a statement of, in this case, a statement of no difference. You have to start with the basis that there is not anything statistically significantly different between these two groups. So I've started kind of the sentence for you here. The wording is important in stats. It's important to be precise. It's not creative writing. You just need to say what you're saying. So in this case, you would say there is no significant, and pretend I can type once again, difference in the average age of people who voted for Clinton and Trump in the 2016 election. Something like that. You will always start your statement, at least for the ones where we're looking at mean difference. So again, that would be t-tests or an ANOVA, where there is no significant difference. You cannot leave out this significant part. That is one of the words that matters, because there will always be some kind of, it's called an observed difference, right? Just there's always going to be some difference between people, because people, right? What we're interested in as a quantitative researcher is looking for mathematically, statistically significant differences. Now, some people also hear the word significant and they think, oh, well, it has to be a really huge gap, right? So if it's a difference of 0.2, that means it's not significant. That's not true. What we mean by statistically significant is just that, again, it's not due to chance, that the difference here is due to whatever factor, right? So if you pursued this field further, then you would get into more complicated studies where, you're controlling for something, you start weighting other factors, you add in other measures to kind of flesh out that test and help explain those differences. That's what quantitative sociologists do, right? So these will obviously be simplistic, but just know that this isn't the stopping point for most research, and that, again, you want to make sure to be precise in the wording, so that, okay, thanks, Microsoft Defender, because the wording does matter. You have to be pedantic when you're writing this stuff. Okay, there's all of that. So if you go over to, where is my cursor? There it is. SPSS, we will go to Analyze, and then we are going to go down to, oh my goodness, Compare Means, and we are doing independent samples t-test. You see there's a whole bunch of different ones here. This is the one that we are doing. So if you are, however, I don't even know how long I've been recording for, 10 minutes, you've somehow made it 10 minutes and you're like, I've had enough of this guy, I want to watch a different video, then that's totally fine. Just make sure that you look up the right type of t-test, because as you can see, there are a lot of them. So we're going to do this one. Again, right click, display variable names. So we're testing the mean difference, right? So test variable is age, right? Because I've told you, right there. And then our grouping variable, i.e. the categorical variable that has the groups, is pres16, which is right here. I've already told you which group is which, but it is important that if you were doing this by yourself, like when you say, do your second data analysis report, you need to know which, like if it starts at 0, for example, it could be 0 and 1. So you have to specify right here. But we're using 1 and 2. It's very easy. We just hit continue. You do not need to mess with anything else over here. Like this is all extra stuff. So after you've done this, you just hit OK and it will run and you get a table. So the very, very first table that we have here is kind of our descriptives, right? And it breaks it down by group. So you can see that the average age of people that voted for Clinton, right? Because this is age, and then we have it broken down by Clinton, Trump. The average age was 55 of people that voted for Clinton. There was, out of this entire sample, that was 1,400 people. And then the average age of people in this particular group, this particular sample, that voted for Trump was 59 and some change. And that was about 960 people. So that's just your descriptives. That is the information that you'll put in this table. And actually, let me just zoom in here a little bit. Okay. Mean age of those who voted for Clinton is 55 years. And those who voted for Trump is 59.15 years. Awesome. Okay. So this table right here is the one that actually includes your test. This you can ignore. It's extra stuff that we are not touching in this course. So pretty much everything that you need is going to be from like, oh my goodness, like right here and to the left. So the first thing that I'm asking you for here is this t value, right? So you'll pretty much always just want to read the top row. Also, this is a feature of this course. This is not always the case, but for the purposes of this class, I only ever want you to read this top row. So this t statistic right here, this is basically if we did this in the olden times and you were calculating it by hand, this is the number that you would be calculating by going through all these like 2,000 people. And that is kind of sort of what determines your significance, because you go through, you calculate this t value, excuse me, and you compare it to a list of tables that someone made, kind of like the Z table. And then that would tell you if it's significant or not. But that is no longer the case. However, it is important to still report whatever your t statistic is for a t-test, and to kind of know what it represents. So we have, you can just do, also for all of these, you can do 2 decimal places. So it's -616. I'm also going to unbold that. So your next number that you're looking for is this DF, which stands for degrees of freedom. Degrees of freedom represents how many cases you can have within a given sample that can vary like drastically without it being kind of weird. And that kind of represents more or less like the size of your sample in a lot of ways, and also the strength of the test. There's a lot of theoretical stuff around what it is, but again, this is a number that is important to know. Please always note, degrees of freedom for any of these tests, it is always a whole number. Somehow, some way, even though I know I say it when I teach this class in person, I have said it in other videos like this that I've made, it is always a whole number. And even though I tell everybody to read the top row, sometimes people still report this. I don't know why. If you have a decimal in your degrees of freedom, I'll tell you right now, it's wrong. For any of the tests, that is the wrong number. So go back and just reconsider for a little while, you know? Okay. So then the very last number that you will need for this is your p-value, which your p-value is what you compare to the alpha that I've given you, or if you were doing this on your own, whatever alpha. So this table gives you now a one-sided P and a two-sided P. Again, if we were doing this, in person, and this course could be structured a little bit differently, given the university's requirements, then we would look at the difference between these two. But basically, what a one-sided P is looking at does a one-tailed test where you only care if the difference is in a particular direction. So if you were wanting to, say, increase sales, right, between you run a flower shop, and so you have sales figures, you make all of your associates watch a training video that I bet is so awesome and not cringe and super engaging. And then you would expect that your second, you take sales figures afterwards, that you would want an increase, right, in sales. You would want that difference to only be on one side of a normal curve. You would want it to be on the right side, right? You don't want your sales to go down. That's bad. So that would be an example of a one-tailed test. A two-tailed test just basically means that the difference can be on either side. It can be an increase or a decrease. It doesn't matter. Only that there is a difference of some sort. So you should not look at the one-sided P. You should only look at the two-sided P. Here, whenever the decimal is very, very small, it will just say that it's less than 0.001. That is okay if that's what you write. In older versions of SPSS, it would just say 0.000, which that obviously wasn't the case. It was not 0. It was just an itty bitty decimal. And I wonder if it still does. Oh, no. It used to, if you hovered over it, it would tell you the tiny decimal, but I guess not anymore. That's fine. Be like that, SPSS 30. So, like I said, here you can literally just type this. So this is the kind of number one thing that you need to be able to do in this course is understand decimal places. What you're interested in seeing, what you need to know in order to do this last part, is if this number, whatever your p-value is, whatever this number is, it will not always be 0.001 or less than 0.001. You need to know if this number is smaller or larger than this number, than the alpha. So it's always 0.05. If it is smaller, that means that you would reject the null. So the null, again, is saying that there is no statistically significant difference between these two groups. But, like I was saying before, we know that there is an observed difference, right? I mean, we can see there's a difference of 4-ish years, right? What we're interested in is if there is a statistically significant difference. This number being smaller than 0.05 means that it is, which means that you are rejecting this statement. You say, nope, that's BS. There is a difference. So, actually, I'm going to keep those questions there just for ease. So, you would say, oh my goodness, I reject the null hypothesis, period. That's it. You don't need to say anything. You don't say, I accept, nope, I reject the null hypothesis. If, for example, actually, maybe I'll cook one up after this just to show you. But if, for example, this was 0.1, which is obviously bigger than 0.05, then you would fail to reject the null hypothesis because it has not reached a level of statistical significance. So this is the first part. The first question that you're answering. You say, I reject the null hypothesis because your P is less than 0.05. If you reject the null, which in this case we are, What is the mean difference in age between the two sets of voters? Well, that's also, incidentally, it's right here. So, let's see. On average, those who voted for Trump were 4.14 years older than those who voted Clinton in the 2016 election. That's it. That's all you're doing. And then, for example, in your data analysis report, you would fill that out with comparing it to other research or whatever. Don't worry about that. But just, this is the gist of what you're doing, right? That's it. And that's the end of it. So when you go do number 2, you'll do the exact same thing. Let me see if I can just invent something here really fast. Oh my goodness. Okay. Wow. That took like 4 whole minutes. Okay. So I did this one wrong, but I wanted to get a table where you could see a non-significant one. So you can see here, this was if they felt that their neighborhood was affected by air pollution in the last year, and then how many hours they were spent online per week, like on average. This air pollution variable actually has more than 2 categories, so you wouldn't be able to do a t-test on it anyway. I just needed something for the sake of example. So you can see here that this is 0.06. Obviously 0.06 is larger. It's greater than 0.05. Thus, if you were doing this, if this was the question, say that these were the numbers for this, just as an example, then what you would write instead, and I'm going to put that in blue, again, this is just an example, you would say, I fail to reject hypothesis because the p is greater than 0.05. There is no significant difference in the average age of individuals who voted Trump or Clinton. Oh my gosh, Clinton. So that would be your statement. And then obviously you would fill this in with whatever relevant data. So if I wanted to use the exact variables that I used just to get some tables that had numbers in them, I would say I failed to reject the null hypothesis because my p-value was greater than 0.05. There's no significant difference in people who felt that their neighborhood was affected by air pollution in the last year at all, and those who felt that it was slightly affected by air pollution and the amount of time that they spent online. Anyway, something to that effect. And you make sentence sound good. So that's pretty much what you're doing. In the second one, there's a big red asterisk here, and it's in the footer, but you do need to recode here. It's not a complicated recode. You are just dropping down people into, I think degree has, if they have like a high school degree, a college degree, and then like advanced degrees. So you're just separating, recoding whatever those categories are down into they don't have a college degree and they do have a college degree. So you use, kind of your discretion at that, right? And then you'll do the same steps. Again, 2 decimal places is totally fine. Be precise in your language. Use the whole number for degrees of freedom, not the crazy decimal one. read the top row for the purposes of this class. And what else? Make sure that you're looking at the correct, the right decimal to compare to the 0.05 number to whatever alpha. Like if this was a one-sided test, for example, 0.03 is obviously smaller than 0.05, so you would reject. 0.06 is bigger, so you would fail to reject. Be precise in the language. Obviously, if you have questions, as always, please just email me. Yeah, that's pretty much it. So, bye.